Hello everyone, I'm Larry from Freaks team. Today I will show you the practical operation course of CPU A8, disassemble and assemble. Next, I will tell you what is the failure of the CPU. The first case, small current. The boot current is between 20 to 40 mAh. Unable to boot. This is a failure of the CPU. In the second case, the RAM doesn't work. Current about 0.07 swing back and forth repeatedly. This beating current is also a fault of the CPU. We generally call it the current of RAM. The third case is that the flash cannot be completed. Flash is in DFU mode, and the Apple logo will not light up when flash. Flash cannot switch from DFU mode to recovery mode. Stuck in DFU. This is also a CPU failure. This situation, also the CPU RAM is not working normal. There is a function that it is not working properly. A certain line is loose. We can measure the resistance of the pins of the chip pad. Check which lines has no resistance. If you check the CXW while it is to the CPU, it may also be a loose of the CPU. There is also a situation where the CPU is short-circuit and power on with a large current. We can use rosin, also known as flux paste, to smoke the CPU. When encountering a large current during the startup and the CPU is hot, we can measure the resistance of several lines. Let's take a look. We open CXW and find the schematic of iPhone 6. iPhone 6 and iPhone 6 Plus use A8 CPU. This class is to learn the circuit of A8 CPU. Find the CPU and zoom in. This is the first line need to be measured. Measure the capacitor C1214. This is a 1.2 voltage power supply to SD RAM. There is a short circuit here. Basically, the upper RAM is short circuit. The second is the CPU SoC 0.95 voltage core power supply. Test the third one. This is the power supply for CPU. Test the fourth one. This is the SoC power supply line. Test capacitor C1289. Look down. Capacitor C1277 PPGPU power supply circuit. Note that this is a low voltage line. Its resistance value is sometimes dozens, but it is normal. Other lines' values are hundreds. This is also a 1.8 voltage power supply line to RAM. These 6 lines in total. If you encounter a large current at startup and the CPU is hot, we can measure whether these 6 lines are short circuit. Sometimes the inductors in those lines is hot. For example, one of the two inductors is hot. Then there is a problem with this line. Now look at the lines of iPhone 6 Plus. First, look here. Capacitor C1216, 1.6 voltage power supply line. This is the second line. SOC 0.95 voltage power supply. That is the capacitor C1202. The third line. This is the power supply for the CPU. That is the capacitor C1262. The fourth line. SOC power supply line. That is the capacitor C1289. The fifth line. CPU power supply line. That is the capacitor C1227. The sixth line. That is the capacitor C1293. Just measure these 6 lines. Why do you need to measure? It can be seen that the red point inside the CPU is grounded. If the CPU is not installed properly, the tin bursts outside. Even tin point and tin point connect. The red point is ground. If the blue point connect red point, then we cause short circuit, and the CPU will not work. When we remove and install CPU, we also need to check those 6 lines. Next, we take a look at this phone. This phone, the function is normal. Now I'll show you the A8 CPU, the disassembly and assembly. Take out the motherboard. We need to remove the shell before we handle the CPU. We keep the motherboard in the PCB holder. As long as the motherboard repair, we need the PCB holder, so that the motherboard will be more stable during we repair. Remove the shell. A161D hot air gun set the temperature to 380. And the nozzle is used the small one. Use the twister to pry out the shell. To remove the CPU, first we need to clean the glue around it. The tool we use is this curved blade. If the blade is new, we need to use a sandpaper for polishing. Polishing, it be not sharp so that not easy to hurt the motherboard. Temperature 320, air 30. Use the nozzle, focus on the CPU edge and cut the edge glue. Remember to remove the hot air gun when you can easy to cut the glue. You can hit one time and cut one time. If the glue is strong, you need to hit it a little longer. Like this, the blade is easy to move. The air gun can be shifted. This is safer, and it is not easy to damage the CPU and the small components nearby. Of course, the influence of this temperature on the CPU is not particularly great now. But for safety, we still have to use this method. Like this, the glue is finished and the hot air gun is shifted. Edge glue only needs to cut both sides. The rest of other two sides don't need to cut, because these two sides have not the small components. I will tell everyone about the function of cutting the edge glue. If you don't cut the edge glue, it is easy to bring the small components also when we remove the CPU. After cutting the edge glue and blowing the CPU, it will not bring out other components together. After cutting the edge glue, you can disassemble the CPU. I use the integrated disassembly method, remove the CPU lower layer and RAM at the same time. If one layer by one layer to remove, it is easy to deform. Of course, you can remove it one layer by one layer, depending on personal preference. I will show you guys the integrated disassembly method. Now change other blade. We need to use this kind of blade to remove CPU. And the blade should be more thin. Let's start to pry the CPU. To pry CPU, we have to take care in some points. We need to use blade like this. Try it, the edge of CPU. Remove the air nozzle from the air gun and blow it directly. It can make it more evenly heated, and it is not easy to let pins drop when removed. Air gun temperature 390, wind speed 40. This is a straight air gun. The model of the air gun I use is Sunshine 861. Temperature 390, wind speed 40. If it is other air gun, such as Quick 881 or Quick 2008 Cyclone gun, their temperature is a bit lower than Quick 861D, because the temperature of the straight air gun is generally higher. Therefore, when using the Cyclone gun, it can increase by about 15 degrees, according to my current temperature. This temperature value is not absolute. I just give you a reference. If you have a colder environment, adjust the temperature a little higher. If you have a hotter environment, lower the temperature. Therefore, the temperature of the air gun is adjusted properly according to its actual situation. The air gun just aims at the CPU, and then the hand must be rotated. Let the CPU heat evenly. When blowing, the blade can be cut gently like this. so that you will know that the tin is melt or not. If the blade can enter a little, the tin inside that place will melt almost. The blade can be inserted. You can prepare to pry open the CPU. The air gun should be pressed a little bit closer to the CPU so that you can pry it off. Then observe whether the CPU has drop points or dropped the insulating layer. First, look at the pad. There is no drop points or dropping the insulating layer. You can see it is perfect. Now clean the pad while the pad is still hot. Add 183 tin paste to the pad. Put the flux into the syringe and use it will be convenient for subsequent steps. First, clean the pad. The original tin of the pad is difficult to melt. So we need to use the low temperature tin to mix it. This will facilitate the removal of tin and black glue to mix each solder point. After mixing once, use the soldering wick. Use the solder wick to clean the tin and also can clean the glue. The corner position should also be clean. In the process of cleaning, the black glue will also be cleaned out together. Of course, the follow-up still need to remove the glue. The first pass is completed. Next, use this type 11 blade. Use the back of the knife to scrape the glue. The air gun is equipped with a small nozzle. The temperature is the same as that the just removed edge glue. Temperature 320, wind speed 30. While blowing with the air gun, remove the glue with the back of the knife. Slowly deal with the edge glue. If these glue are not clean, it is easy to operate the CPU and cause it not to be installed well. So the glue on the edge and the pad must be clean. Just clean it up. After cleaning, we have to add 183 tin again, because there are still some points that have not been mixed into tin. We need to add the 183 tin a second time. The processing of the pad requires 2 times of tin. It can be seen that after the tin is put on, every point is very mellow. This also helps to install the CPU. First, flatten the pad. After leveling, check if there is any pin drop out. We need to make a jumper in the drop point. Repeat the action just now and use a solder wick to clean tin. Clean the pad. The pad of the CPU should be flattened because the CPU has many points. Not flattening will lead to different points in different levels, or even tin points connect and poor contact. These are the cause of poor CPU installation. The pad is processed. Clean it. After cleaning, check if there is any point drop on the pad. If there is a pin drop, it is necessary to make a jumper. It is very common to see the pin drop of the CPU, especially on the phone that has been dropped. We also have to learn jumper in the CPU, so we must check the drop points carefully. This is the process pad. Now it is time to observe carefully. Observe the pad. Teach you guys how to judge useful points without the CXW software. This point without lines and pins underneath is definitely the pin of the NC. But watch this place. There is a yellow pin underneath. We look at the CXW. What is the role of this pan? Let's compare. The point corresponding to the CPU is the 8 in the 4th row. Let's look at corresponding point on CXW. This is the GPS line. GPS and baseband line. This line is definitely useful. The blue one is the MC pin just mentioned. It is useless. Continue to check what else is missing. This part is no problem. There is one here. Let's take a look. Although there is no line underneath, but it has pin next to it. This is a useful line. The corresponding position on the pad is the 7th pin. This is the 7th corresponding pin on CXW. This pin is useful. It is an LCD line. Okay, we go back to the pad. Now 2 points have been dropped. Continue to observe if there are other drop points. These are also NC. No pins, no matter. Here are 2 more missing points. Then let's look at these 2 lines again. Look at the first point. This is a touch point. The second is the camera point. These are useful lines. Next, I will show you the jumper of the CPU pad. The most common and simplest. First, scrape the pins. Prepare to add tin after scraping. Scratch the other two too. The jumper of this pin will be more difficult. Scrape this pin deeper, which is helpful for adding the tin in this pan. After scraping, we are making a jumper line by line. When remove a CPU, we'll often encounter this situation. The CPU problem due to the phone's heavy fall. It should be a function point drop out. Or virtual welding, easy to fall off. So we have to learn the techniques of making jumper on the CPU pad. Now I'm showing you the technology of making jumper on the CPU pad. The first step is to apply thin paste. Apply the thin paste to the points just scratched off. Then jumper. Clamp the wire with tweezers. Adding flux will better help you jumper. Put the wires to the pin position of the pad. Then touch it with the head of the soldering iron. This is already welded. Wrap the wire with tin. Next, add flux first. Place the wire first. Then solder it up with a soldering iron. This jumper is also completed. The third jumper, the same method of operation. If you feel that you are not jumper well, you can jumper again. It is also difficult to jumper in the corner. Put it in place and solder it on. The point of this pin is more difficult to jumper. The same method of operation. The point of this kind of pin is more difficult to jumper. A few more clicks. In this case, the tin is not enough. You need to add a little tin. Otherwise, the welding is unstable. This kind of pin's point is very difficult to solder and easy to fall off. So we must pay more attention to the welding this kind of pin point. Wash it with the PCB water. If it doesn't drop the line, that means it is okay. This line has dropped. Then we need to make up a little thin and solder it again. It is stable now. After washing, blow it with a hot air gun. The PCB water will evaporate more quickly. Before adding green oil, the flux above must be cleaned. Adding green oil. Apply green oil to the welding place. It doesn't matter if you add a little UV to the point next to it. You can use a blade to remove it later. Recuring with purple light. After curing, we will circle the previous jumper wire. Observe whether the curing is good. Well, it has been cured. We need to circle the previous jumper wire. If the line is longer, you can cut it short. Just simulate it as the same dot on the pad. Remove the excess green oil on the side. If the green oil is not removed, the solder point will be insulated. This solder joint is also okay. Deal with this pin. Circle the jumper line. The same technique, jumper line to circle. Clean it. Done. All drop points has been jumper. Next step, processing CPU. CPU is the same as the pad. It is also at 183 tin. Chain a small quarter head of the soldering iron. Clean the original tin. Mix it with the 183 tin. This quarter head is used because the CPU can be directly clean glue. Add the flux, and if you see the black glue shoved off, this is the roll of the quarter. This glue has been burned down by the soldering iron. It is easy to remove the glue with the small quarter head. It will not cause solder joints or insulation to fall. Use solder wick to flatten the solder joints. Clean it. You can start to reball after cleaning. Remove the glue around the CPU. Layer the CPU after coating the edge glue. A8 CPU has 2 layers, so it needs to be disassembled in layers. Observe the CPU. You can see that there is a gap. See how I layer. Still use this blade. Hot air gun without the nozzle. Temperature 390, wind speed 40. See how to layer. Find a corner. Slide the blade into the gap. Just enter a little bit, don't push too hard. Use the air gun to rotate and blow evenly. Don't force on the knife. The knife will go down naturally after the tin melts. It can be seen that the knife goes down slowly by itself. Complete separation. Look at the effect of separation. Solder joints and glue are very complete on it. For the next step of removing tin, keep this hole in the critical step. The upper layer is perfect. Let's learn about the processing of the middle layer first. Use the PCB holder to fix the middle layer. The first step is to scrape the glue, not to clean the tin. This step is very important. If you remove the tin first, there will be a lot of glue into the hole. It will cause tin not to be powered into the holes, and the size of the tin points is uneven. So it is necessary to remove the glue first and then clean the tin. Install the small nozzle in the hot air gun. Temperature 320, wind speed 30. Scrape the glue. Keep the blade on the same surface of the glass. The air gun cooperates with the blade to remove the glue. Next is the surrounding glue. The surrounding hard glue should also keep a flat surface with the glass. Cannot be high or low, must keep in the same level. Keep flat and slowly remove the black glue. Thin dots are also shown directly, provided that they remain flat with the glass. Remember, it is important to keep them in the same level. Place half of the blade on the glass to ensure that they are in the same level. Here is the part where we have been removed the glue. And here is the part where we have not removed the glue. It can be seen that there is a sharp contrast. The reason for removing glue is to ensure that these points are on the same level when installed. To ensure that the points will not be short-circuited. Continue the process, the glue on all four sides. Don't worry, you must make sure it is level. These are black glue. According to our layering, the thin dots and glue inside are kept intact. If it is layer by layer to remove the A8 CPU, it is difficult to retain such a complete. This is the safe step method. Look at the effect of removing glue. You can see all the points are on a plane, very flat. After removing the glue, use this thin wire to replace the original paint. Add flux around. Use thin wire. You can let the tin be a ball and more easily to clean it. If you use the tin paste, the tin will spread out. So when dealing with the middle layer, I suggest using thin wire. Continue to take away the tin. Remove all the tin, and after that, the tin needs to be changed. Alright, after finishing, ready to clean. Use cotton. Hold cotton with tweezers and wash with PCB water. No debris can be left in it. If there is debris, the tin will not fit. I will just clean it out, and after that I will show you to see what kind of debris. Check it out. This is the black glue in the hole. This is the sundries. Like this place, there is the black glue in it. These are debris. If these debris are not cleaned up, then you cannot pour tin into it and fool it. Then the dots will become smaller and uneven. Tin filling in the core part of replacing A8 CPU. Let the tin dots in each hole become the same size. Not one big and one small, some high and some low. This is the core of A8 CPU processing. We continue to clean this group. Tin cannot be full in the holes if the group is not clean, so it must be clean. More cleaning is no damage to the CPU. Be sure to wash more. This is the state after washing. You need to check if there is any foreign matter later. This is the state after filling. Check if there are any foreign objects in each hole. Here is very clean. Just like the small foreign objects here, we must remove them. Clean it. There is a black glue. If this is not removed, there is no way to add tin at this point, and a tin ball of uniform size cannot be formed at this point. Other points are beautiful. The next step is to pour tin into this middle layer. That's it. Fill the tin into the hole. Let's see how to add. Hold this tin and press down. After this pin is pressed, let's take a clean dust-free cloth. Use this plate to wipe it clean. Now it is wiped clean. Let's look at why we need to press tin in it at this time. Observe this place. The tin will run into the hole, and after the air gone to blow it up to become a tin ball. You can see there is a tin in this hole. Now put the CPU here. Then use the hot air gun. Air gun temperature 320, wind speed 30. Blow this tin up. Okay, so it's blow up. After blowing it, I found a problem. See this place. This tin point are uniform. Why this one uneven? This verifies what I did not check carefully just now. Verify what I just said. There is a glue here. Take it away first. There is a glue. This solder joint must be bad. So we have to check this glue carefully. There should not be residue. Other glues are gone, as is the case now. If you put it again now, the middle solder joint cannot meet the requirements. So we shovel it be flat. Because some solder points are large and some solder points are small, we shovel it flat. In this way, large solder points can be cut and small ones cannot be shoveled. Because we need to press tin one more time. One time is not enough. Usually need 2 or 3 times. We continue to shovel. Next, you need to continue pressing tin. Now look at the shovel places. The place where the light shines is the relieved large tin bread which have been cut. If other small tin breads will not be shoved, because it has not met our requirements enough. We continue to shovel and fill the tin. After filling, we will perform the action just now to wipe it clean. What is the meaning of continue pressing and filling the tin? Because like the soldering points just blocked by the black glue before, now all the tin is filled in. The original soldered points are just a small amount of tin covering. Then we will need to blow the tin. Don't let the tin ball run up. After blowing, after the tin be curing, and shovel it again, verify it. In this time, basically, you can shovel most of the tin holes. This shows that tin in this hole is already full and they are on the same level. Because this honeycomb pad is not as flat as the CPU pad. Let's take a look now. The surface we have shown will be reflective. Most of this has been shown. This shows that the tin in that part of the hole is full. At this time, we can install it because it had 70% coverage reflective. And now, no need press more tin. This honeycomb slot will never feel to be flat because the hole in this honeycomb are different size. Reflective hole surface can reach 60 and 16%. You can install it. The next step is to reball. Before reball, clean the tin ball nearby. Clean it. Start to reball. Take out the tissue and fold it twice. Put the CPU on it. Then clean the reball stencil. Clean. After cleaning, use your fingers to pop out the dirt inside. Then check it under the microscope. You can start Reball without foreign objects. First of all, counterpoint. Then take the 183 tin out. Use tissue paper. Tin must be dry to reball easily. Press to absorb moisture. Take out a pair of curved tweezers and a pair of straight tweezers to plant tin. The temperature of reball is 320. The wind speed is 30. Then plant tin. First, the first part is aligned. Wipe the tin after correct positioning. Press upward and apply tin. Use teaser, press again the lifted place. If the reball stencil swells up, it's most hard to reball. The role of the curve twister is to press wherever is listed, where it is pressed where tin is implanted. When this part is finished, the twister moves over. Hold the middle with your fingernails. Take out the dust-free cloth and wipe it. Use twister to press the diagonal position of the reball stencil. Blow around with a hot air gun to make it evenly heated, so that the reball stencil will not bulge and affect the tin point. The air gun moves with the direction of the tin point dissolving. Don't rush to remove the reball stencil. First, check the solder joints. There is one pin that it is not welded. We add a little flux and blow it with the air gun. If the tin dots stuck in the stencil, you can use twister to press down. Okay, now. Wait for the cooling to take off the reball stencil. Reset after removing. Add flux. Reset. Now the solder joint is shiny and uniform in size. Next, you can install the CPU. This is the path just processed. Take out the cotton and wash it. Although this path has been cleaned just now, it needs to be cleaned before installation. Pay attention to this line when washing. You need to return to the original position if it's cow. This is cow by the cotton. Next, smooth in the pad with rosin and soldering iron. Because the rosin is sticky, the CPU will not slip. After some rosin, add some flux around. This way welding will be better. The installation of the CPU is in accordance with the pin, so we have to see how to install the CPU. First, the CPU pad has a yellow arrow here. This is the A1 pin. There is also a point on the front of this chip that is also on the pin of A1. Then we switch to the computer screen and take a look. There is an arrow when the mouse moves here. This is the A1 pin of the chip. They are correspond. So the pin position is in this direction. Turn the chip over. The gaps around need to be adjusted. The gap on each side should be adjusted a little. The distance is probably like this. This side will widen a little. Adjust it again. Adjust the peripheral gap evenly. Like this is okay. Check the gap between the two sides. If you cannot find the filling to adjust the gap, you can make a mark before remove. It doesn't matter if there is a deviation now. There will be a reset process later. Temperature is 380. Wind speed 30. Installation can be a little lower than remove. The wind speed cannot be too high to blow away the CPU. Use a small nozzle to heat evenly this place. Observe this CPU carefully. Just wait patiently to heat the surrounding area evenly. You can see a slight reset process. The installation is complete and the thin dots have melted. Then it needs to dissipate heat. Use a small fan to dissipate heat. Reset is to move the chip back to the corresponding position, which means that the installation is complete. You can only reset after all the thin spots have melted. If the thin dots is not complete melt, it cannot be removed. After cooling, measure the power supply of the 6th line of the A8 CPU according to the previous description. Use a multimeter to check it. Measure every line power supply of the 6 lines. The first line. This line has value, normal. Clean the black glue. The second line, normal. The third line, normal. Fourth line, normal. Fifth line, normal. Sixth line, normal. According to the current circuit measurement, there is no short circuit, which proves that the CPU is installed well. Then we look at the change in current. Install this and observe whether the current is normal. We trigger the boot by pressing the power button to check the current. 0.08 to 0.098. The current will jump back and forth repeatedly. Is that what I said at the beginning, is that the upper cover RAM does not work. It is this kind of current. Remember, the upper cover RAM does not work. The current will jump back and forth repeatedly. If it is in iPhone 7 6s, it will swing back and forth at 0.05 to 0.068. It is normal to swing back and forth between 0.07 to 0.08. This represents the single lower layer and have data. The current will swing back and forth. If the NAND has no data, just empty, that is DFU mode. Now the lower layer has been installed well. This operating current without RAM is normal now. This phone can be turned on and the NAND is normal. Power on. The NAND has data, so the current swings back and forth like this. If you have flash or have been changed the NAND, then the single lower layer connect to the computer is DFU mode. The current will be fixed at 0.07 to 0.088 and will not swing. This is also normal, only means it has no data. So a single CPU without the NAND is also the current, because the NAND has data, so it is normal to swing back and forth. Then continue to deal with the RAM. The treatment method of the RAM is the same. As long as you learn a skill, basically you can use in the CPU universally. Apply this 183 tin first. Then take off the solder joints of the original tin. Use the solder wick to clean it. If this kind of oxidation point is rubbed with the suction tin for a few times, it's still same. No need to worry, you can plan it when you reball. It can be seen that the solder joint has been taken off. There is also glue in the middle, hanging with the back of the knife. Adjust the temperature of removing glue 320, wind speed 30. Deviation of 1 to 2 degrees within 10 degrees are irrelevant. Now clean the glue. It is easy to clean the glue. scrape them all. In this way, the glue of the RAM is clean. It is very easy to clean it. At this time, you also need to clean the edge glue before install and reball. After clean, we can reball it. The reball of the RAM will be easier than the CPU. Clean the stencil first. Bounce off excess water after cleaning. There must be no foreign objects in the middle hole, or thin cannot be reballed. After checking that there are not foreign objects, I like the holes. Clean the foreign objects. If there are still foreign objects, you need to clean it again. Just like tin filling, there is not foreign body to plant tin. Wipe the solder joint. Align well. There will be no foreign objects. Then reball. The principle of reball is to press wherever it swells. For example, if this place swells up, it must be flattened with tweezers. Thin dots reball is this way will not be bigger or smaller. After planting tin, you can relax this place, because the tin there has been powering in. It doesn't matter if it swells, but the position cannot be moved. Then process the remaining part. Done. Use dust-free cloth again to clean the remaining impurities. Now start to reball. Preheat the stencil and other places first, so that the stencil will not upheave. Blow it. The nozzle follows the melt place. Small IC and big IC are same steps. Don't rush away after reball, removing it after it be cool and solidify. After taking it away, check if there is any problem. If no problem, reset. Reset. Take out the board, just install lower layer and prepare to install the upper layer. Before install the RAM, you need to cut the upper coin. Shovel is harmless. You can shovel several times. Just shovel big thin dots into small thin dots. After shoveling, wipe the middle layer with the dust-free cloth. Clean it. This state is perfect. Clean it one more time. This state can be installed directly. Add some flux. Using the air gun to install and add flux will be more uniform. But can't blow too long. Tin will not melt at this time. The purpose is to melt the flux. You can see the yellow arrow on the A1 pin of the cover is very conspicuous. Cover it. Align with the lower layer. Move a little further here. Install the lower layer. Temperature 380 and wind speed 30 for blowing and melting. Blow evenly. Observe the RAM. There will be a small movement if it melts. A bubble appears to indicate that it is about to move. The RAM has been moved. We reset it gently. Successful reset and installation completed. Cooling. Wait. Follow the step to test the 6th line just like the lower layer. Let's test the resistance of those lines just now. The first line, okay. The second line, okay. The third line, okay. The fourth line, okay. This line is a low voltage line, and it is no problem. The fifth line, okay. The sixth line, okay. The last one is okay. If all resistance are normal, we need to test the current. Observe if there is any problem with the current. (0.08, 0.09) start up. Turn on OK. The current jumps up. This is the current for normal boot. Next, install the housing to test. You can see that there is no problem after booting. The A8 CPU installed successfully. See if you can enter the system. Please wait, the boot time of 6+ will be longer. Successful boot. The actual operation process of A8 CPU disassemble and assemble is completed here. The summary of this lesson is that the disassembly and assembly of A8 CPU focus on: first, the middle layer treatment must pay attention to the shoveling glue follow the glass face. Second, there must be no foreign objects left in the planting tin hole. Third, remember to test the 6 points after each step. If you install the lower level, you have to test those 6 points. You can see the current after testing. Because current is dangerous, if the line is short and power supply, it will cause burnout and breakdown. So you must first use a multimeter to test whether the 6 lines are normal before you test the current. When you have some missing points in the CPU pad, don't need to be nervous. You can jumper one by one. If the insulating layer of the pad basically need no worry. But we must cover the insulation layer of the CPU. The above are the details of the A8 CPU course. The next class is the A9 CPU course. And also have A10, A11, A12 and A13. The details are the same, but they are also different. So for the next class, everyone should study hard. See you in the next lesson.